Okay, hello everyone. Welcome back to week 2 of critical thinking. So let me just make a few comments about week 1. There were a number of you that did really well on the first quiz, and a few of you didn't do as well as you would like, I think. So I added an extra credit assignment to week 1, and I intend to add extra credit assignment going forward for every week. So if you're struggling a little on the quizzes, don't get too stressed. Just make sure you post in the discussion section, and then also do the extra credit, and you'll get through the course okay. But that doesn't mean you shouldn't try as hard as you possibly can on those quizzes. Okay, so let's move into the week 2 content. So last week we learned about the basic structure and component parts of arguments. So we learned about premises and conclusions, and also trying to understand the difference between arguments and non-arguments. And remember, the difference there was that there's a relationship between something that's being supported and some evidence that's providing the support. That's what makes an argument a logical argument. Everything else wouldn't qualify as a logical argument. So now we need to begin to understand that arguments come in two common types, deductive and inductive. So this whole section will be about distinguishing between the difference between deductive arguments and inductive arguments, and looking at the evaluative criteria. In other words, starting to look at the standards for deciding whether those arguments are good or bad. Okay, so since our overall goal in this course is to be able to critically evaluate arguments, it's important to recognize the difference between deductive and inductive arguments, as I just said before, because deductive and inductive arguments succeed and fail for different reasons. So we have to be able to see when we're dealing with a deductive argument versus dealing with an inductive argument, because when they are successful and when they fail, they are successful and they fail for different reasons. Okay, so let's start with the definitions here of just basic deductive and inductive arguments. Okay, so a deductive argument is an argument where it's impossible for the premises to be true and the conclusion false. So for deductive arguments, the premises provide definitive support for the conclusion. So when you're thinking about deductive arguments, if they are constructed correctly, a poorly constructed deductive argument wouldn't meet this standard. But if they are constructed correctly, and we'll talk about what correctly means later on here in this presentation, if they are constructed correctly, the conclusion follows with absolute necessity. There's no way that if the premises are true in a deductive argument that is constructed correctly, that the conclusion could ever come out false. Deductive arguments are sort of the ultimate argument. If they are done properly, you could never refute a deductive argument. Now, inductive arguments, on the other hand, they're arguments that claim it is improbable that the conclusion is false if the premises are true. So in inductive arguments, there's a probabilistic link between the truth of the premises and the truth of the conclusion. So in an inductive argument, even if it's constructed as well as it possibly can be constructed, best case scenario, it's only highly likely that the conclusion follows. You can never get complete certainty with an inductive kind of argument. So that's a pretty clear distinction. Deductive arguments, if constructed correctly, they provide definitive support for the conclusion, just couldn't go any other way. In inductive arguments, even if they are constructed as well as they possibly can be, they can only provide highly probable support for the conclusion. Okay, so let's look at some examples of types of deductive and inductive arguments. Okay, so here are some common types of deductive arguments. Arguments based on mathematics, arguments from definition, categorical, hypothetical, and disjunctive syllogisms. So we're going to go through each of these types and look at an example for each to give you a better idea of what deduction is. Okay, so let's start with an argument from mathematics. 8 is greater than 4, 4 is greater than 2, therefore 8 is greater than 2. The conclusion, therefore 8 is greater than 2, could not have come out any other way. It couldn't have been false if you assume that 8 is greater than 4 and 4 is greater than 2. So in most cases, mathematically based arguments, even a simple mathematical equation like 2 plus 2 equals 4 is technically a deductive argument because nothing else could follow. 4 has to follow from 2 plus 2. Now, not all mathematical inferences are deductive. There is such a thing as mathematical induction, but the vast majority of mathematical inferences are deductive. So, generally, if you see math being used as a primary component of the structure of an argument, you should think to yourself, this is probably a deductive argument. Now, if the math is statistical in nature, depending on how it's used in the argument, it could actually be an inductive argument because statistical arguments are only probabilistically true. The conclusion only follows with a certain degree of probability from the premises. So, but if it's non-statistically based mathematics, then you're almost always dealing with a deductive argument. Arguments from definition. So birds are animals with feathers. Parrots have feathers. Therefore, parrots are birds. The conclusion, therefore, parrots are birds, could not have come out any other way. If you accept that it's true that birds are animals with feathers, and then you state that parrots have feathers, then it follows that parrots are birds. With the stipulation that birds are the only animals that have feathers. That's implied in the first premise in that argument. So any argument that begins with a stipulative definition just says, here's what this thing is, and then draws a conclusion from that is almost always going to be a deductive argument. So categorical syllogisms. Now, a syllogism is a deductive argument with two premises and one conclusion. So any deductive argument that has two premises and one conclusion is considered a syllogistic argument. These are the kinds of arguments that the Greek philosopher Aristotle studied. He pioneered the study of syllogistic logic. And so later on in the semester, when we get closer to the end of the course, we'll look at some of the techniques Aristotle developed for evaluating categorical and hypothetical and disjunctive syllogisms, but we'll see that in more detail later. Okay, so here's an example of a categorical syllogism. All dogs are mammals. All mammals are things that have hair. Therefore, all dogs have hair. Argument couldn't have gone any other way. It would be impossible for you to believe that the two premises are true, all dogs are mammals and all mammals are things that have hair, and reject the claim that all dogs have hair. Now, this is called a categorical syllogism because if you look at the two premises, all dogs are mammals and all mammals are things that have hair, what's going on is those premises are relating categories of things. The category of things that are dogs to the category of things that are mammals. And then a second premise, the category of things that are mammals to the category of things that have hair. So that's why those types of syllogisms, we have two premises, one conclusion, so it's a syllogism. In those premises there is an attempt to show a relationship between categories of things, hence a categorical syllogism. Okay, so then we have hypothetical syllogisms. So hypothetical in logic just means if-then type statements. So that means we have a deductive argument with two premises, and at least one of those premises contains an if-then statement. So the example I have here is if you love candy, then you love ice cream. You love candy, therefore you love ice cream. Right? So if it's true that if you love candy, then you love ice cream. If that statement is actually true, and it's true that you love candy, it must follow with complete certainty that you love ice cream. So it's a hypothetical syllogism once again because it has an if-then statement in it. Then we have disjunctive syllogisms. Now, disjunctive in logic just means either or, an either or statement. So two things stuck together, disjunction. So the example I have here is you're either a Republican or a Democrat. It's not the case that you're a Republican, therefore you're a Democrat. So you have two options, and I understand that there are more options. You could be a third party candidate, the Green Party, the Communist Party. But if you only have two options, if it's true that you only have two options and you eliminate one of those options, so if we eliminate the option of being a Republican as we did in the second premise, the only thing that would follow is that you're a Democrat. There'd be no other option. So that makes it a deductive argument because the conclusion follows with complete necessity from the assumed truth of the premises. And it's a disjunctive syllogism because it has two premises and there's an either-or statement in there. You are either a Republican or a Democrat. Okay, so let's look at the common types of inductive arguments. You have arguments based on a prediction, based on an analogy, arguments from authority, arguments based on signs, and then causal inferences. These are all typical examples of inductive type arguments. So let's go through each of those. So a prediction, here's a good example. Every time in the past when I put my hand near fire, it has been burned. Therefore, if I put my hand in that fire, my hand will be burned. So in that example, I would be predicting what the outcome will be in the future. And so since it's a prediction, it's almost certainly going to be an inductive argument. And you might say, well, don't we know with certainty that if we put our hand in fire, it's going to burn? Technically, we don't know with certainty. It is possible that the future could be different than the past. If the laws of physics changed, for example, then it might be possible to put my hand into a fire and it wouldn't be burned. And that seems highly unlikely, and that's what makes this argument a very compelling inductive argument. The conclusion follows with high probability. It's very, very likely that my hand will be burned if I put it in the fire. But we can't say for certain just because we don't know with complete certainty that the future will be exactly like the past. I know that sounds kind of crazy, but if you think about it in a theoretical, philosophical kind of way, the future does not have to be like the past. We've got a lot of evidence that the future ends up being very similar to the past, but it doesn't mean it will always have to unfold that way. So an argument based on a prediction will almost always be an inductive argument. Then you have arguments from analogy. So an analogy is a comparison. It's when you're comparing two different things that are similar. So in this example, I say the meerkat is closely related to the suricate. The suricate thrives on beetle larvae, therefore probably the meerkat thrives on beetle larvae. So the idea here is that these two animals are so similar that they probably have similar diets and behaviors and so on, so therefore they would thrive in the same conditions. Now, arguments based on comparison are good and compelling if the things you are comparing are very similar, but if they're not very similar, then the argument is very weak. So in this case, the claim is that it's a very strong inductive argument because the meerkat and the suricate are very, very similar biologically, anatomically, behaviorally, and so on. So anytime you see an argument based on a comparison, you're dealing with induction. It has to be induction because the comparison is never completely perfect, and so since the comparison is never completely perfect, it's possible that the conclusion doesn't follow. So that would make it only probabilistically true. Okay, so then an argument from authority. Anytime someone references an authority figure to draw a conclusion, then you're dealing with an inductive argument because the authority figure could be wrong. And so since the authority figure could be wrong, it means the conclusion only probably follows. So the example I have here is world-class physicist Stephen Hawking says that black holes dissipate over time. Therefore, it's likely that black holes dissipate over time. Now that seems to be the case from making astronomical observations, that we don't know for sure that we won't find a black hole that doesn't dissipate over time. So, you know, arguments from authority are not the most desirable arguments. We'd prefer direct proof, but sometimes, for example, in this case, where it requires special and advanced expertise to prove such a claim, then we have to defer to somebody who's an expert in the field. So Stephen Hawking was a world-class physicist, and so given those credentials, we could refer to him as an expert in the field. Black holes, in fact, were one of his primary areas of study. Now, if I used the wrong kind of authority figure, it would make the argument much weaker. If I said Lyndall Rowe, I'm a philosopher, says that black holes dissipate, then that's not a particularly compelling argument because my area of expertise is not black hole physics. So the strength of an argument from authority is based on how authoritative the actual individual is that's being referenced. And then you have arguments based on signs. These are pretty simple. The road sign in front of me indicates that there's highway construction ahead. Therefore, there is probably highway construction ahead. Usually, when you see a sign on the road that says construction ahead, there's construction. But we've all encountered instances where it says there's construction ahead, and there's no construction going on. They just forgot to take the sign down. Last night when I was driving to Southeast College, they had construction signs up on Interstate 530, and so when I got to the place where the construction was supposed to be, they'd moved the barrels out of the road, and there wasn't any construction going on. So I couldn't infer from a road sign in front of me saying there's construction with certainty that there's construction, but generally that's the case, that it's true. So it's an inductive argument. Conclusion only follows probabilistically from the premises. And then we have causal inferences. A causal inference is when you're making the claim that one event causally follows from another. So the example I have here is when the sun rises, the temperature rises, therefore the heat from the sun must cause the temperature to rise. So we're making a causal claim based on this correlation between the sun rising and the heat increasing, the temperature rising. So correlations are indicators. Multiple correlations are indicators of some causal link. So if we only saw the sun rise 3 times and the temperature then rose, and we concluded that there's a causal link there, that probably wouldn't be a compelling argument because we only have 3 instances of observation. But if we've seen it 50 years of our life, then it becomes more compelling that the sun rising is causally linked to the rise of temperature. But it's possible that the sun could rise and the temperature didn't rise one day. For example, as I said before in one of the other arguments, the laws of physics could change. The future could be different than the past. Seems kind of unlikely, but it is something that's logically possible. Okay, so those are our types of inductive and deductive arguments with different examples of forms of induction and deduction. So there will be a point on the quiz for week 2 where I ask you to identify deduction and induction, or deductive and inductive arguments. Remember, the key here is to ask yourselves, is the conclusion, first find the conclusion, locate your premises, and ask, what is the relationship between the conclusion and the premises? What's the relationship between the evidence that's being offered and the thing that's being supported by the evidence? Is it a relationship of necessity, or is it a relationship of probability? If it's a relationship of necessity, then it's likely a deductive argument. If it's a relationship of probability, then it's likely an inductive argument. Then also remember all the argument forms that we went through. So if you see one of those forms pop up, then you know you're probably dealing with that particular type of argument, either inductive or deductive. Okay, so let's try to tackle validity, truth, soundness, strength, and cogency now. Now these will be the most challenging concepts conceptually probably for the entire semester. Students historically have had problems understanding these concepts. Now, I don't expect you to be world-class logicians after listening to me talk about this on some PowerPoint slide. I'm just trying to get the basic concepts conveyed to you. And then the exam, or the quiz questions that I give you will be fairly reasonable in relation to understanding these concepts. So let's start with a valid deductive argument. So the term valid is used very technically in logic and in critical thinking. Valid only refers to deductive arguments. You would never use the term valid to refer to an inductive argument. So same thing goes for the term invalid. We're going to cover both of these in this slide. So those two terms, valid and invalid, are evaluative standards or evaluative criteria for determining whether a deductive argument is good or bad, whether the premises actually support the conclusion, in other words. So I know in everyday life we use the term valid in a very loose way. We might say, oh, you have a valid point, or I can see your point is valid, and so on. That's a different use of the term valid than the way it's used in logic. In logic, it's used very precisely and technically. In fact, the way we're going to define them here on this slide. So let's go with valid deductive argument first. So a valid deductive argument is an argument in which it is impossible for the conclusion to be false given that the premises are true. Now you might ask yourself, well, doesn't that just sound like the definition of a deductive argument that we were given earlier? Technically it is, because the definition of a deductive argument that I gave you was a definition of a valid deductive argument. But understand what's being conveyed here. When we say a deductive argument is valid, it means that the structure of the argument, the way the terms are arranged in relation to each other, the way the statements interact with each other, it makes it impossible for the premises to be true and the conclusion false. So in a valid deductive argument, the logic of the argument is such that you just can't have true premises and a false conclusion. If the premises are true or assumed to be true, the conclusion must follow as true also. And that's the best form of a deductive argument, because it gives us absolute proof of the conclusion. The form is correct, or the pattern, if you want to think of it that way, is correct. Now on the other hand, an invalid deductive argument, these are arguments in which it is possible for the conclusion to be false given that the premises are true. So if the pattern is not correct, it's not correct in the sense that the premises do not really support the conclusion, then you're dealing with an invalid deductive form. And it can get tricky because it's possible to construct deductive arguments with invalid forms that look like they are valid, and we'll talk about that a little later. So once again, valid means it has the correct pattern, so the premises really do support the conclusion. Invalid means it has the incorrect pattern or an incorrect pattern, and the premises don't really support the conclusion. They might appear to support the conclusion, but they don't really provide evidence in support of it. The conclusion just does not follow, the truth of the conclusion doesn't follow with the necessity. Okay, so let's add to that soundness. So we have validity and we have invalidity. Validity means good pattern, invalidity means bad pattern. So soundness means that you have a valid argument form, meaning that you have a good pattern and all the premises are true. That's important. So there are two components to the success of an argument. Arguments have to have the correct pattern. They have to inferentially link together in the right way, the premises to the conclusion. And the statements that are in the argument actually have to be true. Just because somebody conveys to you a bunch of truthful statements, it does not follow that the argument actually provides support for the conclusion, because the pattern of the argument has to be correct also. So people can dupe someone into accepting an argument, a conclusion of an argument, by generating arguments that have poor patterns but true premises. So that's why it's important to understand this basic distinction. When you're evaluating arguments, you're dealing with two layers. You're dealing with the truth layer, and you're dealing with the pattern layer, or the inferential link layer. So for a deductive argument to be sound, and sound only applies to deduction. Validity, invalidity, validity, and soundness only apply to deduction. So a deductive argument to be sound, it has to have a valid form, and it must have all true premises. So the example I give is all flowers are plants, which is true. All plants are things that contain chlorophyll, true once again. Therefore, all flowers are things that contain chlorophyll. Now, the pattern I've given you in this argument is a valid deductive pattern, and we'll learn later on in the semester how to determine whether it's a valid pattern. But at this point, Just assume that it's a valid pattern. So the pattern is correct, the premises are true. It follows then that the argument has to be sound. Okay, so let's just clarify a little bit here. It's possible for a deductive argument to be valid but not sound. So I want to give you an example of how that could happen. So the pattern here, all dogs are cats, all cats are birds, therefore all dogs are birds. That's the same pattern that I gave you on the previous slide. It's just different terms. I've stuck in dogs and cats here. So the pattern is the same, so it's actually a valid argument. The way the premises link together and then link to the conclusion actually provides support for the conclusion. The problem is all the premises are false. Dogs are not cats, cats are not birds, and then we end up even with a false conclusion. All dogs are birds. So all of the argument is valid, it has the correct pattern. Since the premises are false, we consider it to be unsound because it's lacking truth. So to get soundness, you have to have truth plus validity. If you're lacking truth, or if you're lacking validity, or if you're lacking both, you're dealing with an unsound argument. So let's clarify a little more here with deduction, because deduction is usually the trickiest one. It's also possible for a deductive argument to be unsound because it has an invalid form. So the previous example we looked at an unsound argument because the premises were false. Now we're going to look at an unsound argument because the form is bad. The way the argument is structured is incorrect, but the premises just happen to be true. So even though it has all true premises and true conclusion, the argument still ends up being unsound. So all German Shepherds are dogs. That's true. All canines are dogs. That's true. Therefore, all German Shepherds are canines. That's true. So the premises are true and the conclusion is true, but I changed the pattern from the other argument. The terms are arranged differently. Right? I've got dogs, the two terms that are shared between the premises, stuck over here on the ends of the sentences, and we'll talk about what all those positions mean later on in the semester. But since I changed the pattern, it happens to be a bad pattern or an invalid pattern where the premises don't really provide support for the conclusion. So even though all the statements are true, there really isn't enough evidence up here in the premises to allow us to conclude that all German Shepherds are canines. And if you look at it, you can see it pretty easily. Just because German Shepherds belong to the class of things that are dogs, and just because canines belong to the class of things that are dogs, you still don't have enough information to conclude that German Shepherds and canines are the same thing. We happen to know that they are because of our experiences in the world, but if you were an alien just put on this planet, you knew nothing about German Shepherds or canines and dogs, looking at this logically, you wouldn't be able to have enough information to infer that all German Shepherds are canines. I could plug in other examples and show you easily. I could say keep the same pattern but put some different terms in. I could say all sparrows are birds, all blue jays are birds, therefore all sparrows are blue jays. True, true, false. So I was able to show by keeping the pattern the same and plugging in three different terms that it's possible to have true premises and false conclusion in this argument pattern. And that's a way of showing that arguments are invalid. But don't be so worried about that. I'm just trying to show you the logic of how it all pieces together. So once again, what we have here is an example of a deductive argument that has an invalid form, a bad pattern, but the premises are all true, and since it has a bad pattern, it makes the entire argument unsound. The conclusion is not really supported by the conclusion. I mean, the conclusion is not really supported by the premises. Okay, so let's talk about induction now. So we looked at the evaluative standards for deduction, valid, invalid, and sound. Now we're going to look at the evaluative standards or the criteria for critiquing or evaluating inductive arguments. So let's start with strength. So a strong inductive argument is an argument in which it is probable that the conclusion follows from the premises. So when we say an inductive argument is strong, what we're saying is that it's likely, given the truth of the premises, that the conclusion follows. Now, what does strength boil down to? It usually boils down to how many observations you have of the thing that you're inferring. So if I say all ravens are black, but I've only seen one raven, that's not a strong argument because my number of observations is very, very low. That would be a weak inductive argument. If I've seen 5,000 ravens, the argument has gotten considerably stronger. So strength is generally a result of the quantity of observations of the particular event or thing you are trying to make an inference about. It's a little trickier than that if you really get into the granular aspects of induction, but for our purposes, think of strength as, do I have enough observational instances? So then, with that in mind, a weak inductive argument is an argument in which the conclusion does not follow with high probability from the premises, even though it is claimed to. So my raven example where I've only seen one raven, that would be an example of a weak inductive argument. 5,000 ravens, much stronger inductive argument. So strength and weakness indicate how much actual observational support you have for the conclusion. So when a inductive argument is strong, meaning you have enough observational instances or enough evidence, if you want to think of it that way, and all the premises are actually true, then we call that argument cogent. Cogent just means convincing. That's the definition of cogent. So the best an inductive argument can be is convincing. So the raven example I gave you, the first one, I've observed one raven, therefore all ravens are black. That's not a cogent argument because I don't have strength. I'm lacking enough observations. It might be true that I observed one raven, so the premise is true, but I've only seen one raven, so it lacks strength. Now, if I lied and said I've observed 5,000 ravens, well, 5,000 observations would be enough to give strength, but I'm lying and I never really saw them, then my premises are actually false and the argument would lack cogency also. So in order for an inductive argument to be cogent, it has to have strength and it has to have actually true premises. So I'll give you an example here. All flamingos I've seen so far were pink. This is similar to the raven example. Therefore, the next flamingo I see will be pink. Now, if I've seen a lot of flamingos, then it's highly likely that the next flamingo that I see will be pink if all the previous ones are. Now, it's not certain. There could be a genetic mutation and there's a white flamingo. Those occur sometimes. So it's not completely certain, and that makes it an inductive argument, but it seems to be a cogent inductive argument if we've observed enough flamingos. Okay, so that's it for 1.3 and 1.4, deduction, induction, validity, invalidity, strength, weakness, cogency, soundness, and so on. So if you have any concerns about any of this, and some of this is a little difficult, don't hesitate to email me. And remember, if you're worried about low scores on the quiz or something of that sort, make sure that you do the discussion correctly and make sure you do the extra credit work that I post for every week. Thanks, and see you guys next week.